So good afternoon everyone. I have asked you the question that momentum is conserved, okay, in an isolated system, and during the collision, after the collision, before the collision, momentum is same. Okay, so what are the concepts we have used to arrive at this conclusion that momentum is conserved? Newton's second law, Newton's third law, Newton's second law and Newton's third law, or concept of conservation of energy? The correct answer is option 3. Okay, so let us derive this relation that momentum before collision is equals to momentum after collision. Okay, now when the two systems collide, the mutual impulsive forces, they act over the collision time. Let the collision time be delta t, and they change their momentums. So let the change in momentum of the first body is the force applied on it multiplied by delta t. So what have we used here? Newton's second law. Newton's second law says that what is change in momentum? Change in momentum is yes, F is equals to rate of change of momentum. This is what, and we arrive at F is equals to ma, this concept. Okay, and limit delta t tends to 0, or we can write F equals to dp by dt. So if we have if we are taking on an average basis for time delta t, so this is Newton's second law, and delta t will go this side, and you get change in momentum is equals to F into delta t. So this is what Newton's second law is, right? So this is what I have written, and this is also called impulse. This is impulsive force which acts for a small time, and this is the impulse, and this delta p1 is equals to this. So momentum is changed of first body, and now the change in momentum of the second body due to the collision is given by force acted on the second, the impulsive force acted on the second due to the first body, by the first body for time delta t. So momentum is changed. Now so we have written these two equations, equation number 1 and equation number 2, using Newton's second law. Now so this is according to Newton's second law. Now according to Newton's third law, force applied on the first by the second is equals to equal and opposite to the force applied on the second by the first. These two forces are equal and opposite. That is Newton's third law. So this is equation number 3. Now using equation, you can simply put the value of F12 in equation number 1. So put 3 in first, we get delta P1 equals to minus F21 into delta T. This is your equation number 4. Now add first and fourth. What do you get? We get, so not first and fourth, sorry, second and fourth. Add second and fourth. These two equations. So what do you get? You get delta P1 plus delta P2 is equals to. So this side is same. So it will be cancelled out. And you get a 0. So delta P1 plus delta P2 is equals to 0. So that's and I can further write it as, I can even take the delta common. So if any vector is 0, it means their magnitude is also the same and their magnitude is also 0. So there is no change basically. So there is no change in the total momentum. So total momentum is conserved. It means I can further write it as P1 plus P2 is equals to constant. So even the magnitude is both the things are constant. So that's a constant value, P1 plus P2. Got it, students? So we have. So that's your.
नहीं सर मेरे को नहीं आया.
You have not understood it. Okay. So let me explain it again. It's very simple. I have this object 1 and this object 2. So it has mass m1 and it has mass m2. So suppose they are means there is a collision between them. Its velocity is u1, its velocity is u2. So this is before collision, and after collision the velocities are v1 and v2 and masses m1 and m2. Now when they hit each other, they apply force on each other definitely. So F12. So what is here first? It's 1. So force on 1. Force on M1 by M2 or due to M2. Now I write F2. Okay. So force on M2. But who is applying this force? So write here 1 due to M1. Okay. So what will the change in impulse of F1? Okay. So change in momentum of M1. So that's the impulse of M1. So impulse yes, what will the impulse? That is definition of impulse itself is change in momentum. Okay. Do you know this thing, students?
Yes sir.
Okay. If you have any problem, you can open your NCERT book, page number 94, Newton's second law. Okay. So that's Newton's second law. And then we have on page 96 we have impulse. And we have a numerical also on page 98 based on impulse. So impulse is a vector quantity. And impulse, you can say impulse imparted to M1, you can say. Impulse imparted to M1. So impulse imparted to M1 is change in the momentum of so change in momentum is the impulse. Okay, so that's equals to, so impulse equals to impulsive force into time. Okay, the time up to which the force was applied. Okay, so that's the formula according to Newton's second law. So now the impulse imparted to M2 is delta P2 is equals to F21 into delta T. And according to Newton's third law, the force, that is force on M1, so both are applying force on each other. So objects apply equal and opposite forces. Yes, that is what Newton's third law is. What is Newton's third law? Newton's third law says that to every action there is equal and opposite reaction. If one body is applying force on other, then the other body is also applying equal and opposite force. Okay, so force always occur in pairs. So forces occur in pairs, equal and opposite. So that is Newton's third law. So simply you can say that these forces are equal and opposite. So obviously this quantity is equal and opposite, so it will cancel out if you add both of them. Okay, so this is very simple. You have just put this value over here. So this is minus F21. So delta P1 is equals to minus F21 delta T. Now you are adding these two equations. So this thing is same. If you add, these two will cancel out, and what you are left with? Delta P1 plus delta P2 is equals to, this side is 0. Simple. And one more way to write it is delta P1 plus P2 is equals to 0. If the total change is 0, so it means we can also write it, and if there is no change, it means P1 plus P2 is a constant, means the momentum is conserved. So there is no change, it means Pi is equals to Pf. It's as simple as that. Have you understood the concept? This written
सर ये जो लास्ट में हुआ है ना P1 plus P2 is equal to constant, इसे क्या समझूं मैं?
If there is no change in velocity, what does it mean? If change in velocity is 0, what does this mean? It means final velocity minus initial velocity is 0. This is the meaning of change, final minus initial. So you can write it as, there is no change, this is the total momentum. So P1 plus P2 initial means change is final minus initial. Initial, that is 0. So the change is 0 means final minus initial is 0. So final momentum minus initial momentum is 0. So this means initial momentum is equal to final momentum.
Okay, sir.
If the change is 0 means delta Pf minus, so it means that Pf minus Pi equals to 0. So this is the same thing. So here also, if there is no change, because in the next chapter, chapter number 7, we are going to use this thing a lot in the next chapter. Okay, so I hope you have understood it. So understand it in this way also. If there is no change in velocity, it means velocity is constant. And how can you write it mathematically? Delta V is equals to 0. What is delta V? Final velocity minus initial velocity. So final minus initial is 0. So take minus Vi this side. So it will be positive. So Vf equals to Vi.